Good morning. My name is Mackenzie Vedas, and for my lab experiment 2, determination of specific heat and various heats of reactions, I will be focusing on Part B, determination of delta H RxN for the reaction of NaOH and HCl. So the first thing we're going to do is take a look at some values that I have made up. The only thing that I have not made up are the densities, and they're from the lab. So NaOH is going to be 1.51 grams per milliliter, and HCl is going to be 1.19 grams per milliliter. So we're going to have 60 milliliters of NaOH aqueous. We're going to have 50 milliliters of HCl. Our initial temperature is going to be 25.7 degrees Celsius, and then our max temperature will be 33.4 degrees Celsius. So the first part in the table on Part B is to find Part A, which is the total mass of the solutions. So for NaOH aqueous, we're going to take the 60 milliliters that were from our table, and we're going to multiply it by the density, 1.51 grams per milliliter, and the milliliters will cancel out, and we will be left with 90.6 grams. For HCl, we will be taking the 50 milliliters from the table, multiplying it by 1.19 grams, and dividing it by 1 milliliter, and that is going to be 59.5 grams. Now for the total mass, we'll just add the two together, giving us the 150.1 grams. For Part B, we will be focusing on finding the Q solution in joules, which is equation 2. And equation 2 says specific heat times mass times delta T, so that's the change in temperature, and we will be finding that by taking the final temperature minus the initial, which is down here, so we had the 33.4 degrees Celsius, minus the 25.7 degrees Celsius is equal to 7.7 degrees Celsius. And we will also be using, for specific heat, 4.184 grams, or joules per gram degree Celsius. And the reason we're doing that is the specific heat of water that was given in the pre-lab. And if you combine the HCl and the NaOH, one of the byproducts is water. So what we'll do is we'll multiply our values out. So we'll take the 150.1 grams that we got from A and multiply it by the 7.7 degrees Celsius, which is our difference, and that will give us 4,835.34 joules. Now that number will be taken to be used in Part C, which is the Q. We're trying to find the QRxN in joules. So that just means Q system is equal to the negative Q surroundings. So that just means we're going to take this value and we're going to convert it to negative. So now we have negative 4,835.74. Now we're going to find the moles of HCl neutralized. So for this, we'll take grams, convert it to moles, and we're going to use the molar mass, which is from the periodic table. So when we add H plus Cl, we get 36.46 grams of HCl. And when we found from Part A our mass of HCl, we're going to now be using those grams in this equation. So the 59.5 grams of HCl multiplied by 1 mole divided by 36.46 grams of HCl gives us 1.63 moles of HCl. Now for our final part of this section is going to be Part E, and the reason we're not doing F and G is because we only have time to do one trial, so the numbers are exactly the same, so there's no need to take the average or a second equation for Part E. So our Part E here states that we're going to take the delta H RxN, and that equation is equal to Q RxN in kilojoules per mole divided by the moles of HCl. Now over here on the side, remember it has to be converted, so just an easy way to remember, you're just going to move the decimal place 3 spots over to the left. So now that leaves us with negative 4.83574 kilojoules. So when we plug all the numbers in, we'll have the negative 4.83574 kilojoules divided by the 1.63 moles of HCl, and that will give us a total of negative 2.97 kilojoules per moles of HCl. Thank you for joining me, and I hope you have a great day.